The Spindle galaxy is a quite famous galaxy that we have observed in H1 and parametrized. As Alexei already told you before, this is now to a certain extent the extension of that slide that was shown to you before. First, I don't have to spend too much time on this because Alexei already gave that introduction. NGC 2685 is long considered a polar ring galaxy, and those are systems that are in principle well defined as galaxies with two disks of with orthogonal or two orthogonal systems that are confirmed to be rotating about their spin axis. And the system must also be in sort of an equilibrium. This is sort of a very strict definition of a polar ring galaxy. There's always some transition stages, and I will try to convince you that NGC 2685 is one of those. There's only a few confirmed cases because you need some observational effort to show that such a system is indeed a polar ring system. Why are they interesting? There's a few, only what was 0.5% of all early type galaxies show these polar ring structures. However, you have two orthogonal systems that trace the dynamics of the system, so they can serve to trace the dynamical structure of the galaxy. So in principle, a way to test the 3D geometry of the potential. This is one of the very famous galaxies. But now let's turn to NGC 2685. This galaxy, you have a lenticular stellar body, a fast rotating system with Sauron. Then you have covers a lot of the northern part of this stellar central body. Since the object has been of interest for a while, it has been well observed, and the age of this helix has been estimated to be not that young. As for the polar ring of the former galaxy, it's 4658, that would be a quite young disk, but not for this one. This structure is quite, or say in the middle range for ages. Then there is a faint outer ring that is more or less aligned with the inner stellar body. Now, if you look at it a bit deeper, this is an event observation to the 26th magnitude per square arc second. It shows again this inner stellar body, helix, not as well visible since this is a red color. But very clearly this outer stellar ring. Now it was the H1 observations that made this, that coined the picture of these galaxies, a galaxy as having two orthogonal rings of H1. That coined the picture that this is a clear case for a two-ringed polar ring galaxy. And for the rest of this talk, I will try to convince you that this picture is a bit oversimplistic. And this galaxy is indeed not really a polar ring galaxy in a very strict sense. We're accustomed to this kind of picture of bodies, information about the spatial distribution. This is the event IT image, and this is a high resolution, such an inclined system. We are going to the problematic zones here. With the ring model, this would be then the structure any extension of the tilted ring model that would represent, for example, quite spherical. And the argumentation might, or especially this galaxy. Yeah, there is galaxy. There are simulations of wet mergers, spiral galaxies. We would still expect a different an exponential profile of the interstellar body, which it simply doesn't show. So the best guess for me is that this is the result of a wet merger. And I'm already coming to my conclusions. I hope you don't mind too much. NGC 2685, the famous spiral galaxy, spindle galaxy, has a lenticular stellar body and a heavily warped disk that contains dust, gas, and stars that is wrapped around independently of this central stellar body. We don't see any obvious deviation from circular orbits, which then would imply that the total potential is spherically symmetric. Of course, in principle, this requires additional dynamical modeling to see whether or how this would evolve if we would assume a heavy disk. This is pursued by Anna-Marie Weidand. And well, it's not a singular case for such a galaxy. There's others. It's like NGC 3718 is one of those that shows such a heavily warped structure. I think we have seen some before. One is there. So this is not a singular galaxy, or it's not such peculiar as it might seem. With neighboring galaxies and also the galaxy structure seems to indicate that the formation of these galaxies was through a wet merger. And that's, thank you.